Check one. Right. Good evening, everybody. Back again with our MCQ night session after 2 days. After 2 days. Hi, sir. Hi. Eating? How was your 2 days? First, tell me, is all the duos perfect? Adi appa, battery low. Very productive. Perfect. Perfect. Right. I didn't open the groups, no. I'll open the groups. And I hope by now Western Province people have finished their exams, third term exam. Southern Province, you have already finished it. Central is there. Candy people are there. Yet to finish. Right, groups are open. YouTube people tell me, is all the duos perfect? All good. Any information about Chem Night, I'll give. YouTube, okay, no? Right. Hurry, hurry. Small information about our Chem Night. Chemistry night. I had no any other name to put other than making it Chem Night. Chem Night. The full form is Chemistry Night. What is going to happen in Chemistry Night? It's a night. Chem night anything. Night anything. Is it afternoon? Nan? So it's a night, right? On 3rd February, on 3rd February, 8 p.m. we start the session. Session goes until the next day, until the Independence Day, 4th February, which is a holiday. Until 4th February, 4 a.m. the session will be going 4:15, 4:30, that kind of a time. 8 to next day morning 4, right? Yeah, from 8 p.m. 3rd February to 4 a.m. 4th February. So whole night we are going to stay. Whole night we are going to stay and finish off. These are the sections we are going to finish off fully. fully we finish off. Electrochemistry, what I mean by fully finishing is we learn, put it to the mind, uttaning ivarailamai. From that, again, you are touching that lesson for the exam. That way we learn it. That way we learn it. Now, that night you sit, you learn, you put it to the mind, that lesson finish. 100% finish. From my end, from your end, all the ends it's finished. That's how we are going to touch those lessons. Electrochemistry. It's not like theory session. Theory session theory, not like theory session. That night we sit, we learn, we put it to the mind, finish off. Electrochemistry will be done. Mixtures will be done. What I'm targeting is grade 11 chemistry lesson, because grade 10, most of the chemistry lesson, I have already done a YouTube video, came backup kiyala. That was done for previous batch, right? In came backup, most of the grade 10 chemistry lessons were done. So here we are touching the grade 11 chemistry lesson, where most of the places where you can score. Mixtures will be done. Acids and bases is done. Acids and bases section will be done. Heat changes associated with chemical reaction. Heat changes associated with chemical reaction. Associated with chemical reaction. I'll write in short form. Associated in chemical reaction. All these lessons we learn, we put it to the mind, we finish it off that night. Right? Those have already watched my previous year's physics night. This night session started with previous year physics night. Those have watched my previous year's physics night, they know the flow, how it is going to go. So that is what is going to happen. Yes, it is free. Will be held through Zoom, online, Zoom and YouTube. Don't keep to watch it as a separate video and later finish it. You will not finish it. Live watch it and finish it. That's the value there. That is what you mean by chemistry night. Otherwise, I can name it chemistry morning and give you a video. That night you sit, you learn, you put it to the mind. By the next morning, these lessons are done. That is what you mean by that. So watch it live, we finish it off live. That's the plan. On 3rd Feb. On 3rd Feb. I hope all of you are there in the WhatsApp group. All the new updates I will only send to the WhatsApp group. More updates will come. I'll put it to the WhatsApp group. If you are not there in the WhatsApp group, please join the WhatsApp group. First 3 WhatsApp groups are full. 4th one is also going to be full. Join the 4th one and stay. Okay. That is about chemistry night. Exactly 1 week more. Exactly 1 week more. Next week, next Monday, by this time, we will be doing chemistry night. 1 week to go. 7 days more. If we keep counting days, 7 days more. Next week, this time, we'll be in chemistry night. I will start the session for today without talking a lot. Today, 2021 O-level paper, last 10 MCQ. I think there is nothing there. If you look at the very last 5 MCQ, you will be asking me, sir, is this a science paper? Such a MCQ is given. These four. These 4 MCQ. Direct 4 marks is there. These 4 MCQ. Direct 4 marks is there. Those who did the paper already, I have already put the form in the Google form in the WhatsApp group. Because I did the question already, they know these 4 question guaranteed you have 4 marks. Such a paper. Such a paper. Here there are some things to learn. I think 36th question is nothing. We have already discussed. 35th question, there is something to learn. Other than that, nothing much. Nothing much. Okay. And with today, we are finishing off 2021 O-level paper. All the MCQs are done, which means we are hitting our 120th MCQ by today. 120 mark is reached by today. Okay. Before we start, from your end, get your review book, sit on the table and send me ready. Ready? Already. Perfect. Right. Eyes on the screen. ears on the speaker. Listen very carefully. Question number 31. I will go in the normal order. I'll go in the normal order. There is something to discuss in question 34 and 35. But however, I'll go in the normal order. Listen very carefully. 31. In 2011, the number of elephants in Sri Lanka was 5,879. What is the most suitable biospherical organizational level to demonstrate the number of elephants? Denominate the number of elephants, right? This is what you check for. See, what are the data they have given? They have given us the year. A certain time period is given. Year is given means time is given. Number of elephant, a certain species is given. In Sri Lanka, a certain geographical location is given. Time, a certain species in a certain geographical location. What are they talking about? What are they talking about? Time. If they talk about time, a certain species in a certain geographical location, remember they are talking about population. About what they are talking about? Population. So when you are talking about population, three things you need to check. Time, a certain species, a certain geographical location. Number of organisms that belong to a certain species living in a certain geographical location during a certain period of time is population. So those are the things you check for. So guaranteed, this is population. Direct biosphere question. Direct biosphere question, nothing. Question 32. Select the correct option with regard to an NPN transistor. NPN transistor. Listen, ne? Onna puthe transistor. 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 Remember, a transistor is made of three semiconductor region. Transistor is made of three semiconductor region. Listen very carefully. Three semiconductor region. Two PN junction. Two PN junction. And three terminals. Three terminals. First, put the things into the mind. Three semiconductor region, two PN junction, three terminals. Repeat with me. Three semiconductor region, two PN junction, three terminals. There are two types of transistors. There are two types of transistors. What are the two types of transistors? Number one, NPN transistor. Number two, PNP transistor. NPN transistor, PNP transistor. NPN transistor, PNP transistor. NPN transistor. If you look at NPN transistor, there you go. This region, negative type semiconductor, N. This region, positive type semiconductor, P. Again, this region, negative type semiconductor, N. Negative type, positive type, negative type, N, P, N. Look at this and tell me. How many semiconductor regions are there? How many semiconductor regions are there? Tell me, open the mouth and tell. Can you type and send me? How many semiconductor regions? Three semiconductor regions. Harini? Harini? How many junctions are there? PN junctions are there? How many PN junctions are there? Look and tell. How many junctions? Here one junction. Here one junction. Both together, two PN junction. That is what I was telling. Other than that, how many terminals should be there, Lamai? Three terminals are there. What are the three terminals? What are the three terminals? One terminal is emitter terminal, symbolized as capital E. Next, collector terminal. Now, theory people, you should be able to tell these things. Like a river, these things should go in your mind. Next, base terminal B. So 3 terminals are there, emitter, collector, base. 3 terminals, emitter, collector, base. Remember, center terminal is a base terminal. Always center is base. Out of the other two, one is going to be emitter. If this is emitter, guaranteed the other one is going to be collector. That is NPN transistor. Now your turn. PNP transistor. Your turn. PNP transistor. 3 semiconductor region. Now what are the 3 semiconductor region? P type, N type, P type. Always remember, center terminal is base. Onna puta, that is base. From the other terminals, one terminal is going to be emitter, then guaranteed the other one collector. Okay. Now going to the question. Select the correct option with regard to an NPN transistor. NPN transistor. Collector is negative type. Base is positive type. Emitter is negative type. NPN transistor. Collector negative type. Base positive type. Emitter negative type. This is a famous question. Usually they give this question. So base should be positive type. The other two are negative type. Base positive type. The other two are negative type. Base positive type. The other two are negative type. Answer is answer 1. Those who know even a small thing about transistor can answer this question. Not a hard question. Okay. Okay. That's it. That is question 30. 33. The situation of transverse wave traveling on the surface of water at a certain moment is shown in the figure. Now this is the problem with y'all. Consistency is the problem with y'all. First 2 questions, you have to attentive. Now to WhatsApp. Now to Instagram. That's the problem. That consistency is the problem. Biggest problem. Biggest killing problem that you have. Killer problem. Whatever the that you start, until you finish that work, you should have that consistency. That's the logic here. That's the studying technique. Art and consistency now, with that same discipline, you go to the end. You start today. First MCQ you start. Until the 40th MCQ, you go with that consistency, same discipline. In between, don't allow your mind to roam around. That's a usual thing that human get. Any human, mind going around is a usual thing. But you should have the control to bring it back. Now it's not the time. Only 1.5 months is there. Now it's not the time for you to allow your mind to roam around. Now it's the time for you all to settle your mind, make it stable, focus on one thing. That is your goal. This 1.5 hour, 1 hour, 1.5 hour, you are sitting in this class can get the maximum use. Otherwise, no point sitting here. Right. The situation of transverse wave traveling on the surface of water at a certain moment is shown in the figure. The amplitude and the wavelength of this wave respectively are amplitude and wavelength, nothing big. Amplitude and wavelength. If you know the things, tell with the mind. Again, tell with the mind. Then it again get registered. Amplitude and the wavelength. There you go. You have a wave. I'll draw the displacement. versus distance graph. What is amplitude means maximum displacement of the particle in the wave. Maximum displacement of the particle in the wave. Maximum displacement of the particle in the wave. Onnaputta, this is the maximum displacement of the particle. That is your amplitude. Maximum displacement is amplitude. Wavelength, length of a wave in simple terms. Length of a wave, there's a big definition for that. The minimum distance between two particles taking part in the wave having the same state of motion. That is wavelength. Simply length of a wave. That means this is one wave, its length. That is wavelength. This is one wave, its length. Wavelength. Now look at the graph. Look at the graph. This is given 4 centimeter. That is 4 centimeter kiyanne lamai. Your amplitude is 4 centimeter. No doubt. Now look. 5 centimeter is given for half of the wave. Can you see? Half of the wave is 5 centimeter. Then y'all tell me, full wave, how many centimeter? More simple question, eh? O-level paper. Half of the wave 5 centimeter, full wave 10 centimeter. So full wave 10 centimeter. They are asking what amplitude first, wavelength next. Amplitude 4 centimeter, wavelength 10 centimeter, 4 centimeter, 10 centimeter. What's your answer? Answer is answer 2. Okay. Okay. Perfect. Good. YouTube people, okay. Harinid. Right. Going to question number 34. Question number 34. Which of the following statement is false about electroplating of iron? Electroplating of iron. Electroplating. Electroplating. They are talking about electroplating. That is question number 34. Question 34. Right. Question number 34. What are they talking about? What are they talking about? Which of the following statement is false about electroplating? Electroplating. Now listen very carefully. Electroplating question. Electroplating. Lamai, what is electroplating? Plating a metal on another object using electricity. Plating a metal on another object using electricity. Repeat with me. Plating a metal on another object using electricity. Now, for example, on this pen, I can plate copper. Plating a metal on another object using what I plate? Using a paintbrush? No. I plate it using electricity. Electroplate. Another example. Let's take, you have an iron ring. Iron ring. Lama, you can plate the iron ring with copper. You can plate iron ring with copper. You are plating iron ring with copper. If you are doing this, what kind of setup you need? Now the most important things. Now the most important things, listen very carefully. Most important things in electroplating. Remember, in electroplating, metal used for plating, metal used for plating should be connected to the positive terminal. Metal used for plating, positive terminal. Your positive terminal is going to be the anode. Metal used for plating, positive terminal is the anode. Number two, object to be plated. Object to be plated should be connected to your negative terminal. Negative terminal. Your negative terminal is going to be the cathode. Metal used for plating, positive terminal, anode. Object to be plated, negative terminal, cathode. Repeat with me. Metal used for plating, positive terminal, anode. Object to be plated, negative terminal, cathode. Finally, your electrolyte. Electrolyte කියන්නේ the solution. Your electrolyte should be a salt solution of metal used for plating. Salt solution of metal used for plating. Again, metal used for plating, positive terminal anode. Object to be plated, negative terminal cathode. Electrolyte is salt solution of metal used for plating. Now, if we consider the example, you're plating copper on iron ring. You plate copper on iron ring. Copper is plated on iron ring. Metal used for plating. Lamai, what's the metal used for plating here? What's the metal used for plating? That means what's the metal you use for electroplating? Copper. Copper is the metal used for plating. Copper is the metal used for electroplating. Metal used for electroplating should be connected to which terminal? Which terminal? Positive terminal. That means copper is connected to your positive terminal. It becomes your anode. What is the object to be plated here? Object that is to be plated. Object that is to be plated. Object to be plated. Perfect. Object to be plated is iron ring. Object to be plated should be connected to your which terminal? Negative terminal. That means your iron ring should be connected to which terminal? Negative terminal. It becomes your cathode. Finally, this is the most important one. Your electrolyte, that's the solution, should be salt solution of metal used for plating. Salt solution of metal used for plating. We'll decode this word by word. Salt solution of metal used for plating. First tell me, what's the metal used for plating in this example? What's the metal used for plating? My question is very simple. What is the metal used for plating? What's the metal used for plating? Perfect. Copper is the metal used for plating. Not done. Salt solution of metal used for plating. Salt solution of metal used for plating. Tell me a salt of copper that you know. 11 years you are studying science. At least 6 years you are studying science from grade 6. You should know a salt of copper. Tell me a salt of copper. A salt of copper. A salt that copper forms. Perfect. Copper sulfate. Copper sulfate. Copper sulfate is a salt of copper. Salt solution. Copper sulfate aqueous solution. Onnaputhe. This is what you feel as the electrolyte. Salt solution of metal used for plating. Metal used for plating is copper. Copper sulfate. Copper sulfate is the salt of copper. Copper sulfate aqueous solution. Okay. Okay. So here your electrolyte is copper sulfate aqueous solution. Now if I draw the setup, now when you know this, you can draw the setup easily. Your setup is, there you go. You take your beaker. You all tell me what is filled in the beaker, what solution is filled in the beaker. You all know. What's the solution in the beaker? Copper sulfate aqueous solution. Perfect. Your power source is there, positive terminal. To the positive terminal, what you connect? To the positive terminal, what you connect? Perfect. You take a piece of copper, you connect it as your positive terminal. Negative terminal. What you connect in your negative terminal? Iron ring. Iron ring, negative terminal. Okay. Okay. Going to the equations, reactions, nothing big. Simply it's like this. Your anode is there on copper. It will undergo oxidation. Copper will undergo oxidation. Whatever you connect in your anode, it will undergo oxidation. Copper. What is the oxidation of copper? Copper solid jumps into the solution forming copper plus 2 aqueous solution by liberating 2 electrons. That's the oxidation. Copper jumps into the solution forming copper plus 2 aqueous by liberating 2 electrons. That's the oxidation. What is your reduction? Remember, in electroplating, reduction is very simple. The same reaction, oxidation, listen, the same oxidation reaction, you write it the other side. The same oxidation, you write it in the other side. If you write it in the other side, copper plus 2 aqueous will come there, plus 2 electron. On the other side, you will have copper solid. Copper solid. So reduction is the opposite of this. Same thing, you write it the other side. This is only for electroplating. I'm teaching electroplating only for electroplating. You first write the oxidation. Anode will undergo oxidation. So anode is copper. Copper's oxidation is copper jumping into solution forming copper plus 2 by liberating 2 electrons. That same thing you write upside down. That's reduction. What is actually happening is copper atoms are there on copper atoms are jumping into the solution as copper plus 2 ion. Copper jumping into the solution as copper plus 2 ions. That copper plus 2 ion are going to the cathode, that is your iron ring, and forming copper. That copper plus 2 is going to your iron ring and forming copper. Copper plus 2 is going to your iron ring and forming copper. Copper plus 2 is going to the iron ring and forming copper. Okay. That's what is happening. Finally, how to increase the quality of electroplating? How to increase the quality of electroplating? How to increase the quality? There are two ways to increase the quality. Now, for theory people, I have taught you all with reason how this happens here. Paint a story. There are two ways to increase the quality. One, now you are supplying an electric power source, whatever the power source you are connecting. You connect a power source with low voltage. You reduce the voltage. Of course, when you reduce the voltage, current will also reduce. So you supply low voltage or low current. One way. You get high quality electroplating. Low voltage, low current. Theory people, I have explained how this happens here. How low voltage causes high quality. Second method, you are using an electrolyte. It will have a certain concentration. You reduce the concentration of the electrolyte. Reduce the concentration of electrolyte. Very low concentration electrolyte you have to use. So two ways to get high quality electroplating. One, reduce the voltage. By that, reduce the current. Two, to reduce the concentration. Okay. Again, now we'll say we put the things into the mind. We'll put the things into your mind. Electroplating. What is electroplating? You plate a metal on another object using electricity. Repeat with me. Plate a metal on another object using electricity. Again, one more time, repeat. Plate a metal on another object using electricity. Open the mouth and tell. Let people wake up. Doesn't matter. You have to score. What you do during electroplating? You plate a metal on another object using electricity. There are three rules. Three rules. What are three rules? One, metal used for electroplating should be connected to your positive terminal, that is anode. Metal used for plating is positive terminal anode. Object to be plated, negative terminal cathode. Open the mouth and tell. Metal used for plating, positive anode. Object to be plated, negative cathode. Electrolyte is salt solution of metal used for plating. Salt solution of metal used for plating. For example, plating copper on iron ring. Copper is the metal used for plating, positive terminal. Iron ring is the object to be plated, negative terminal. Copper sulfate aqueous solution is your electrolyte. Reaction. Copper jumps into the solution forming copper plus 2 aqueous, liberating 2 electrons. Repeat with me. Copper jumps into the solution forming copper plus 2 aqueous, liberating 2 electrons. That same thing upside down. That same thing upside down. That is reduction. Same thing other side, reduction. How to increase the quality of electroplating? Reduce the voltage, thereby reduce the current flow, or reduce concentration. What is it? Things in the mind? Clear? Things in the mind? Okay. Right. Now going to the question. Which of the following statement is false about electroplating of iron? False about electroplating of iron. False about electroplating of iron. False about electroplating of iron. I will consider our example itself. You are electroplating iron ring. You are electroplating iron ring. Iron ring. If iron ring is electroplated, you all tell me it should be connected to which terminal? Positive or negative? It goes to the negative. They are not telling what metal they are using for electroplating. Whatever the metal they are using for electroplating should be positive. That's one salt solution should be used as your electrolyte. ඒවට දන්න ඕන. They ask in the false statement. One, an aqueous solution of compound of the metal that is electroplated should be electrolyte. Correct or wrong? Metal that is electroplated. Metal that is electroplated, that one salt solution should be electrolyte. Horini. Metal that is electroplated is copper. Copper is only electroplated on the iron ring. Copper is electroplated on the iron ring. Your solution should be copper sulfate solution. Metal that is electroplated, that one salt solution is used as the electrolyte is correct statement. Again, see, metal that is electroplated, that one salt solution is used as the electrolyte is correct. An aqueous solution of compound of the metal that is used for that is electroplated should be electrolyte. That's correct. Here they are using the word compound. Compound is the copper sulfate. Second statement. The electrolyte should be in high concentration for quality electroplating. High or low? High or low? Understand with the reason why it is wrong. High or low? And it should be low. So this is wrong. They're asking false statement. Third one, iron should be made the cathode of the electrolytic cell. Iron is the cathode. Harini. Negative terminal. Negative becomes your cathode. Iron is the cathode. Correct. Fourth one, the current used should be a direct current. Of course, yes. Now just imagine if you send alternating current, what will happen? Just imagine it. Just think. If you send AC current, you connect a AC current source there. AC current there. What will happen? Current will flow in opposite direction. One time current flows this way, the other time current flows the other way. Next time this way, the other way. Copper will go, it will come. Copper will go, it will come. I think, will electroplating happen? Will electroplating happen? Hmm. Now I'm specifically mentioned positive terminal here, negative terminal there, means you can't use alternating current there, for sure. So current should be a direct current is also correct. You can't use alternating current. So your answer is answer number 2. Understood with the reason why the others are wrong? Understood with the reason why? Understood. Perfect. So before I score 15 or 16 in MCQ, and today I tested myself and I got 35. Perfect. Okay. Right. That is about question 34. Next, going to question 35. Question 35. That's also a good question. Eh? A conical flask containing aqueous hydrochloric acid is kept on a sensitive balance. Pieces of limestone were added to it in excess. Which of the following graph indicates how the balance reading varies against time after the addition of limestone? What and what are reacting? Hydrochloric acid and limestone. Right. Perfect. Hydrochloric acid and limestone. First, tell me the reaction. Hydrochloric acid, HCl, and limestone. Limestone is calcium carbonate. Remember, when an acid reacts with a carbonate, three products are formed. Acid with carbonate, three products are formed. What are the three products? Salt, water, carbon dioxide. What is the salt form? How to find the salt? Negative ion of the acid joins with the positive ion of the carbonate. Always that is how a salt is formed. Negative ion joins with the positive ion of the other compound. Negative ion of the acid joining with the positive ion of the carbonate. Negative ion chlorine, chloride, positive ion calcium, calcium and chloride together. What's the salt? Calcium and chloride together. What's the salt? Calcium chloride. Plus, always remember, acid with carbonate, water and carbon dioxide is a must. Will be released. Will be. If I balance it, if I balance the reaction, one hydrogen here, two hydrogen there. One chlorine here, two chlorine there. One hydrogen, one chlorine, two hydrogen, two chlorine, 1, 1, 2, 2. What's the number in front? What's the number in front? 2. These two are correct. Now, one calcium, one carbon, 3 oxygen, 1 plus 2, 3 oxygen. All the others are correct. Now, what is the question asking? They are telling a conical flask containing aqueous hydrochloric acid is kept on a sensitive balance. Pieces of limestones were added to it in excess. Which of the following graph indicates how the balance reading varies against time after the addition of limestone? Now, your starting part of the graph is after the addition of limestone. See, they are telling after the addition of limestone. How the balance reading varies against time after the addition of limestone. So you start your graph after the addition of limestone. Right. What's the logic you need to use here? Now, I remember when a chemical reaction is happening, no atoms are created, no atoms are destroyed. Repeat with me. When a chemical reaction is happening, no atoms created, no atoms destroyed. Nothing created, nothing destroyed. You can't create any atoms by chemical reaction. You can't destroy any atoms by chemical reaction. No atoms created, no atoms destroyed. Then what will happen during a chemical reaction? Bonds are broken, bonds are formed. That is what is happening during a chemical reaction. Existing bonds are broken, new bonds are formed. No change to the number of atoms. No atoms are created, no atoms are destroyed. You can't create any atoms by chemical reaction. If so, using just small substances, you can create large amount of substances. Practically think if you can create atoms. No, you can't. During chemical reaction, you can't create atoms. You can't destroy any atoms. That means the overall mass is going to remain a constant. Overall mass is going to remain a constant. Why? Nothing is created. If something is created, mass will add up. Nothing is destroyed. If something gets destroyed, then mass will reduce. Nothing created, nothing destroyed, mass is a constant. Which means if the total mass of the reactants is 10 grams, guaranteed total mass of the products are also going to be 10 grams. Why? Nothing created, nothing destroyed. You can't create any atoms, you can't destroy any atoms. Only rearrangement will take place. So if you initially have a total mass of 10 grams, finally also you should have a total mass of 10 grams. But everything should be there in a closed system. You can't leave anything to escape. If something escapes, then you can see a reduction in the mass. Never the mass will increase. If something escapes, let's say carbon dioxide escapes, then practically think carbon dioxide escaping, then reduction in the mass will happen. In a closed system, when you do these reactions, if you start with 10 gram, you should finish also with 10 gram. You will finish with 10 grams. Mass is conserved. This is called law of conservation of mass. What is this called? Law of conservation of mass. During a chemical reaction, neither the atoms are created nor destroyed, which means total initial mass of the reactants is equal to total mass of the products. That's called law of conservation. You start the reaction with 10 gram, you will finish also with 10 gram, but nothing should go out. Why? Actually, why? Practically think. Atoms are just making new bonds. Bonds are broken, bonds are created. That's it. So there will be no change to the total number there. There will be no change to the total number. Now, for example, see, in a certain bordered line. Now, let's say this is a ground. This is a ground. In the ground, two people are joining their hands. X and X is joining their hands. Y and Y. I name the people as X and X. X and X are joining the hands. Y and Y are joining the hands. Z and Z are joining the hands. Mehema, they are joining the hands and waiting. Between X and X, there is a bond. Between Y and Y, there's a bond. Between Z and Z, there's a bond. Just think like these are people. Two people, X and X together. Y and Y together. Z and Z together. This is a covered ground. No one can go out. Now what I do is, I break their bonds and create new bonds. More වැඩි මං කරන්නේ. I break their bonds and I create new bonds. Now let's take this X is joining with this Y. This X is joining with this Y. Z එකත් කඩමුකෝ. This X is joining with this Z. X is joining with Z. Two X's are gone. This Y is joining with this Z. Y is joining with Z. Just their bonds are broken. I made new bonds. See, new bonds are formed. Before X and X, now X and Y. Before X and X, now X and Z. Before Y and Y, now Y and Z. Bonds are broken, bonds are created. Did any new people come in? No. Did any people leave? No. Tell me, what's the total number of people here initially in the ground? How many people are there in total in the ground initially? More simple question I'm asking. Total number of people in the ground initially? 6 people. After the bonds broken, created also, still, how many people are there in the ground? How many people are there in the ground? Still there are 6 people. Let's take each person is 50 kg, 50, 50, 100, 50, 50, 100, 50, 50, 100. Altogether, what's the total mass in the ground here initially? Each person 50. 50, 50, 100, 50, 50, 100, 50, 50, 100. Total mass, kilogram, hey? People, kilogram. Altogether, what's the total mass? 300 kilogram. Now also, after the new bonds are formed also, how much of kilogram is there? 50, 50, 100, 50, 50, 100, 50, 50, 100. How much? A day, 400. How come 400 practically thing? Any new one are formed here? 300. 300 kg. Did the mass change? Can't no, how can the mass change? No new people came in. No anyone left. Only they rearranged. Then can the mass change? No, mass can't change. Mass does not change. Mass will not never change. On that law of conservation of mass. Now apply it to atoms. Understood. Law of conservation of mass. Mm. Okay. What if they eat and become heavier? You. No, no one is eating. Right? Now let's take I have a door open. I have a door open. Now it's not a closed system. Door is open. This Z is telling enemy, I can't be with X. Always troubling me. I will leave. Z is telling I can't be with X. Not replying me. මොකුත් කරන්නේ නැහැ. වැඩක් නැහැ. හරි. ගියා. ඉතින් ගාලා ගියා. Fellow went. If someone leaves, then will it be 300 kilograms still? If someone leaves, will it be 300 kilograms? Now maybe the mass will reduce. So if it is an open system and if someone leaves, maybe the mass will reduce. Maybe මෙහෙමත් වෙන්න පුළුවන්. Why Z is going alone? We'll do like this. X and Z both are going up. ඉවරයිනේ. Still mass will reduce. Still mass will reduce. So that is law of conservation of mass. Now, what are they telling? Now look at the reaction. What are they telling? What are they telling? A conical flask containing aqueous hydrochloric acid is kept on a sensitive balance. Pieces of limestone were added. So HCl is there, limestone is there. HCl is there, limestone is there. Those are the reactants. Which of the following graph indicates how the balance reading varies against time after the addition of limestone? Just after you add the limestone, you start the graph. Just after you add the limestone, you start the graph. So limestone is there, HCl is there. They are just telling a conical flask. You all tell me, does conical flask have any fully enclosed lid? Does conical flask have any fully enclosed lid? No. Is it a closed system? Is it a closed system? No, it's not a closed system. Keeping that in mind, we'll try to figure out. Now just imagine, initially inside the conical flask, HCl is there, calcium carbonate is there. Graph is starting just after you add calcium carbonate. Both are there. Initially the mass is 10 grams. Reaction is proceeding. Reaction is proceeding. If it is fully closed, what should be the total mass at the end? What should be the total mass at the end? Tell. What should be the total mass at the end? 10 grams. If it is closed, 10 grams. But are they telling it is closed? Is it fully enclosed? No. It's not enclosed. Then something can escape. Who is that? Who is that? Some carbon dioxide will escape. So will it be 10 gram at the end? Less than 10 gram. Maybe I'll just mark it as 7 grams. I'll mark it as 7. Now you all tell me, will all the carbon dioxide that is to be formed will be released at once? Or during the reaction, slowly carbon dioxide will get released? What do you think? First or second? Will all the carbon dioxide at once will get formed and released out? Or slowly during the reaction it will form and go? First or second? Slowly the carbon dioxide will go. Then this 10 gram will at once become 7 gram or slowly become 7 gram. At once become 7 grams or slowly becomes unhappy. Slowly it will become 7 grams. Now we'll put it to a graph. Graph only they asking. Balance reading versus time. Initially 10 grams. Graph should go up or down. Y'all tell me, graph should go up or down. Now with the logic, tell me. Never the graph can go up, and during a reaction, never the graph can go up. If it goes up, you are telling from reaction you can produce atom. Graph should go down. At once it should go down, no? Slowly, slowly, nicely, gradually it should go down. Slowly it will go down. Slowly it will go down. Maybe when the reaction stops, it comes to a constant mass. That's the mass of the substance remaining in the solution. Water and calcium chloride. That one's mass. So by that time, all the carbon dioxide is released. Now just imagine, Mehima I am giving. I am adding up the question and I am telling. This is 7 grams. That line is 7 grams. If so, what is the mass of carbon dioxide that got released? What's the mass of carbon dioxide that got released? 3 grams. From that, they can ask number of moles. Himma, you can make the question. They can ask number of moles, number of atoms, uses of carbon dioxide. Okay, now understood this concept there. Perfect. Perfect. I'll remake the question. Conical flask is fully enclosed and sealed. Fully enclosed and sealed. Ehenang what type of graph? Fully enclosed and sealed. What's your graph? If it is fully enclosed and sealed? First one. Initially 10 gram, finally 10 gram, throughout this thing 10 gram. Then first one. But here it is not enclosed. It is not enclosed. Ehenang what type of graph? This one. Then what's your answer? What's your answer? Now what's the answer? Perfect. Understood now this problem fully? Don't get scared when you see graph like question. Some people are very scared when they see graph like question. Okay. That's it. Question 36. Question 36. Number of turns in a primary coil and secondary coil of a transformers are NP and NS respectively. Voltage difference between primary and secondary are VP, VS. What is the correct relationship between number of turns and voltage? Lamai, this one I already discussed. Can remember relationship between number of turns in primary, secondary, voltage in primary, secondary of a transformer. Remember, number of turns in primary coil divided by number of turns in secondary coil is equal to voltage in primary divided by voltage in secondary. First equation in transformer. We already did this. Okay. Then what's the answer? Now you'll tell answer is not there. Think mathematically. The same thing you can write the other way, no? VP over VS equal NP over NS. You can write, no? VP over VS equal NP over NS. VP over VS equal NP over NS. Answer is answer 1. Okay. Last set of question. I don't know for what reason they have put this question. Such question. Question 37 to 40 are based on the information given in the following table. Information related to the method of obtaining energy, lighting devices and cooking equipment used in 4 houses A, B, C, D are given. Method of obtaining energy is given: solar cell, national power grid, blah blah things, lighting devices, CFL, filament, blah blah things, cooking equipment, LP gas, electric heater, those things, right? Question 37. For the energy obtained method of which house is non-renewable energy source used? Non-renewable. Non-renewable means you use it, it finishes off. Which house uses non-renewable energy source? You use it, it finishes off. Solar cell. Solar energy won't finish off. Sun won't finish off. National electric grid. In Sri Lanka, mainly our national electric grid produces current from hydropower station. Never finishes off. Biogas unit, we consider it as renewable. It doesn't finish off. What should be answer? What should be answer? Electricity generator runs using what? Generators. What's the electric source there? What's the source of energy there? Fuel, petrol. Can you remember last year or previous year we were standing in line? Finishes off. Petrol ones are there, diesel ones are also there. So it finishes off. Non-renewable. Answer is answer C. Some students have a confusion with non-renewable, renewable. Renewable means it doesn't finish off. Again and again you can use it. Energy source doesn't finish off. Remember, sun is renewable. Doesn't finish off. Non-renewable means it finishes off. Simply put it in the mind like that. 38. Which house use the lighting device that largely contribute to pollute soil and water when improperly disposed? When you hear the word pollution due to bulbs, CFL should come to your mind. One, CFL. Second, what's the biggest harm? Fluorescent. CFL and fluorescent, big harm, big problem. CFL and fluorescent. CFL and fluorescent. So what's your answer? What's the answer? A and C. A and C is answer 1. Question 39. Which house uses the cooking equipment that minimally contribute to pollute air inside the house? Only inside the house you check. Not outside, not about the production method, nothing. Inside the house. LP, electric heater, kerosene, firewood. Which one? Which one doesn't make any pollution inside the house? Or practical questions, eh? Electric heater. Electric heater. Answer is answer B. Answer 2. 40th one. What's the house that has taken most practical solutions to the electricity and fuel crisis? Practical solution for electricity and fuel crisis. Electricity and fuel crisis. That means everything should be like, renewable, such house. Solar cell, CFL, LP gas, national electricity, filament bulb, electric heater, electricity generator, fluorescent, kerosene, biogas unit, biogas lamp, firewood. These people, no? Even if you have power cut, it doesn't affect them. You have fuel crisis, it doesn't affect them. So nothing will affect them. No any crisis will affect them. So answer is answer D. Fourth. Okay. With that, we finish off our 120th MCQ. And now you can feel how things are getting repeated. Repeated type questions are coming. Then and there we encounter some tough ones, but most of the questions are repeated pattern. Most of the questions are repeated pattern. Okay. Hurry. With that, our 2021 O-level paper is done and dusted. 2021 O-level paper is done and dusted. After the class, just put your marks and go. For this paper, what's your full marks? Compared to the previous two papers, 2023 done, 2022 done. Compared to that, what is your marks, Kila? Just send a message to check how this thing is working. What is chemistry night? Talent forum. About the talent forum, during the session, we take about 20 minutes or 30 minutes. We do a small talent show, online talent show. So in online talent show, the only possible talent that you can showcase is singing and playing some musical instrument. That is like refreshing. Somewhere around it will come around. I'll tell the time. I'll tell the time later. So however, just for a refreshment, we do a small talent show. Last year also it was done. Last year it was suddenly planned. This year I'm inviting this batch, y'all, right? Whoever can sing and play musical instrument, or if you have got any additional thing which you can showcase in a what you call online this thing session, then of course you are invited, right? Fill that forum again. I'll put it right. Already some have filled. I checked. Fill that forum, so you will get the chance to perform. That is that this thing. Okay, right. Before we finish, now I'll not keep you all anymore, right? Power fellows. Um, before we finish, before we finish, one question. 2 days gone. Last time I met you on Friday, Saturday gone, Sunday gone. Today I'm meeting you on Monday. Monday also almost gone. Still the day is not over, almost gone. Are you satisfied with your work that you did on Saturday and Sunday? Send me honestly in the Zoom chat. Are you ask from yourself and ask, are you satisfied with whatever the work you did on your Saturday and Sunday? 2 days and 2 full days. Big things can be changed upside down. Now my people change big things upside down in one single night. 2 days, 2 full days plus today. If your answer is no, now don't think about it. Don't think about it. Hurry. It's gone. Again, I'll be meeting you all tomorrow night. Again, I'll ask the same question after one day. At that time, your answer should be all those who are putting no here, your answer should be a yes. Every day, you should have a satisfaction that today I completed the day fully. Today, I gave my best for the day. Because whatever the best you give these days will surely give you the output at the end. These days, whatever the input that you give, whatever the workload that you put in, that is the work that is going to come out at the end. Don't give up. Don't even think of giving up. Don't even imagine that word. Don't even imagine that. Right? Right? Hurry. Enang, we have come to the end. We have come to the end. Before we finish, 2022, no, wait, 21, 2021 O-level MCQ paper fully done with the reviews. Y'all tell me, what do you feel? What do you feel? What do you feel? There you go, letter by letter. Letter by letter. What do you feel? P, P, next letter. A, next. T, T, next letter. Another T, another T. Last letter. A, there you go. Next. E, next. A, last two. S and Y. Patta easy. Don't forget the hashtag and the signature. Never finish your day with any regrets. I'll meet you all again tomorrow night.